In this segment now, we should now see how to name these coordination compounds, because they are pretty much different than all the compounds that we have studied till today. If you remember, we had nomenclature in organic compounds, or say even naming simple compounds like sodium chloride, we have some policies as such there. So, what are those? When I write sodium chloride, I first write the positive ion, is it not so? Then I write the negative ion. So, what do I mean to say here is that this same sodium chloride, I do not tend to write like this, even though the compound contains Cl and Na, I do not write like this. The general perception is that first write the positive ion and then write the negative ion. What about other factors that are there in these cases? Whenever we write, we balance the charges which are there. For example, sodium is +1, chlorine is -1. Suppose for example, we write these type of compounds also, H2SO4. Now, what does this indicate? Hydrogen is +1, SO4 is 2 minus or -2. So, when I cross this like this, I am going to write it as H2SO4. So, similar sort of things we are going to see in naming of coordination compounds, but the names here are a little big. Please do not be afraid by the size of the names. If you can understand the basic entities of this, it will be very easy. So, one way is just look at the rules, by heart the rules and then try to apply. But we will see a little different way. We will first try to solve some examples and then try to go through the rules that are available. So, let us take the first compound now, which is available. The first compound is Tetramineaquachloridocobalt 3 chloride, pretty big one. So, no doubt it is pretty much big, but let us go word by word that is there. The first part says tetramine. So, let me write it separately like this, NH3 4 times, tetramine. Then aqua, aqua indicates H2O, H2O name is given as aqua. So, after tetramine and aqua, we have another part as chlorido. So, chlorido is Cl. Generally, chlorine we call it as chlorine or chloro, but in coordination compounds we name it as chlorido. And what is the central metal ion here? It is cobalt, and they tell that it is in +3 oxidation state, and the counter ion which is there is nothing but chloride Cl which is there. So, let us segregate it like this to understand it pretty much easily. Now, what is we have to understand is, this entire part is going to be the positive part. For example, when I take NaCl, Na is the positive part, Cl is the negative part. Exactly in the same way, what I am going to do now is, this full segment is going to come under positive part, Cl is going to come under negative part. So, how do I write the formula? What are the procedures for that? The procedure is, first we have to include the central metal ion which is there, and since this is the coordination part, this will not ionize further. So, how do we start up is, we take a square bracket, put cobalt. Do not worry about the charge that is given here. What does this 3 indicate is that it is in +3 state which has been present. Now, let us start putting the ligands that are there, and one easy factor for you is that whenever you are given a name, it will be given in alphabetical order. This you can be pretty much sure. So, when you write these ligands also, you have to write it in alphabetical order, and do not be very much confused. Just write the order of ligands according to the name that is there. So, what did the name say? First it started with tetramine. So, let me, after writing this cobalt, let me write NH3 4 times. Afterwards, the name said H2O. Let me write it like this. Now, I am not going to put a bracket for H2O because it is of 1. But what happens is, generally because this is one full compound, we tend to put brackets in this cases, and then we have chlorido. After that, I am going to close this bracket, and then because my counter ion is chloride, so I am going to write it as Cl. Now, one thing you have to understand here is that inside whatever you write, you have to tell how much it is there. Tetramine, aqua, it means 1, chlorido, it means 1. But outside what you write, they do not tell it as dichloride or trichloride or monochloride. That is to be understood by us as to how much it should come. And how will you understand that? See, this is a neutral ligand, so the charge is 0. Water is a neutral ligand, so the charge is 0. This is plus 3, it is given in the question, so this is plus 3. Inside there is only 1 because they give chlorido. So if you have to balance this compound now, the problem here is that we have 1 Cl inside which is giving you minus 1. Outside there is only 1 Cl. So if I use just these two, it will become minus 2, but this is plus 3. It will not be a stable compound, which means that this compound should have a formula Cl2. Once again, let me repeat it. Inside, if you write the name, in the name itself they would have told tetramine, aqua. They are given chlorido, so I have written 1. They would have given dichlorido, I would have written 2. But outside they will only give you chloride. So how you have to analyze is depending on the charges which are there. Plus 3 is this, minus 1 is this. So inside the overall charge now is my plus 2, plus 3 minus 1. So this plus 2 needs to be satisfied by people outside, and that is why you need a 2 compound. So if you see the name of the formula now, the name that was given to you, you can see that cobalt, amine, water is once again written in bracket because as I told you, this H2O which is there is a combination of hydrogen and oxygen, and whenever there are more than one compounds, we tend to write it in bracket. Chlorido is there, that is why I have written just 1 Cl, Cl2 because of balancing. Remember that Cl2 is primary valency, all other people are secondary valency. So this is one example, and I hope you got a little bit of an idea now. So for this, now let us see the second example by which I hope that you get a little more better idea. What is the name of the compound? Pottasium tetrahydroxozincate, which means that potassium is on one side, that is the cationic part in this cases. If you see sodium chloride, how do you write sodium chloride? You write sodium space chloride. So here also it is exactly the same, potassium space. It means that the potassium is a positive ion. What are present in negative parts are, they are telling tetrahydroxido, which I can write it as OH4, and then they are calling it as zincate. Why is that 8? That we can see later, but for now what we shall see here is that potassium is on the positive side, on the negative side it is tetrahydroxidozincate. So how will I write this? First write the positive side, potassium. What is the negative side now? That is the complex. This is the complex part now. So ZnOH 4 times. Please see the charge that was there in the question there in that example. You will see that the charge given there was plus 2, which means that that plus 2 is actually present on zinc. If this is plus 2 and we know that OH is 4 OH are there and each of OH is minus 1. So which means that the overall negative charge is minus 4, the plus 2 charges of zinc. So how many should be present outside? If I write only one potassium, it will be plus 1. We know potassium is plus 1. Just see the count of this, what is happening here, plus 1 plus 2 is only becoming plus 3, this is becoming minus 4. So to balance this, I told you if it is outside the coordination sphere, they don't give di, tri and all that. That we have to understand ourselves. That is why the formula becomes K2ZnOH 4 times, and when I name it, it is potassium tetrahydroxidozincate. This is how we tend to write the name of this compounds. Hope a little better idea now. Let us go to the third one, third example that is present here. It is potassium trioxalatoaluminate. Please follow the same procedure now. Let me start doing it here. Maybe for you can follow it up. Potassium is the positive ion that is being present. The oxalato form which is there is nothing but C2O4. These minimum examples you will have to know by yourselves. So let us see now which is the parts here. So the positive part is potassium. The negative part which is there is this oxalate ion and aluminum has plus 3 charge. That is what they are told. And they are told that there are trioxalate ions. So let me start writing it, K in the bracket, let me take it AlC2O4 3 times, because this is tri, and whenever you write a complex, first you write the central metal ion and then ligand. Now what is the charges here? Count on charges. This is a didentate ligand, we have already studied in part 2. Didentate ligand means it will give 2 electrons, and how many such didentates are there? 3. So in total the charge on this will be minus 6. and aluminum is already told to be plus 3. This is told in the question itself. So, if this is minus 6, this is plus 3, this has to be plus 3 if it has to stabilize, and we know that potassium can give just plus 1. So, how many such potassiums you will need? You will need 3 such potassiums, and therefore, the formula will be K3Al(C2O4) thrice. That is what the formula you are able to see here, K3Al(C2O4) thrice. So, I hope this should now bring you on par with understanding how do we write the formulas. Let us see the fourth example here, which is now Dichlorodobis, ethane 1,2, diamine, cobalt 3. So, what is this part now? Let us not be afraid of anything, but understand here one thing, that this is given in one straight line, which indicates that there is no counter ion available. So, in the first earlier examples, you had potassium as a counter ion, chlorine as a counter negative ion. Here there is no counter ions. So, what all are present, that let us first note it down. They are told that cobalt is in plus 3 oxidation state. They are told that dichlorido, which means 2 chlorine atoms are available here. They are also told bis ethane 1,2 diamine. Now, what is this bis indicate here is that, so in these cases now, bis is taken because in the name itself already ethane 1,2 diamine is there. And what is ethane 1,2 diamine? We have already come across this. So, in the short form we write it as En, that is the short form that we use, but it indicates that there are 2 electron donor pairs which are available. So, in this case now, when we write this compound, this first, if it is multiple, we write it as di, tri, tetra, but if there is already present in the name, we then go for another nomenclature called as bis, tris, tetrakis, pentakis. This is the nomenclature that we follow. So, that is why what does this indicate is cobalt is in plus 3 state, then after that they have told that it is dichlorido, and En is also present in 2 forms. So, because they are told bis ethane 1,2 diamine, bis indicates 2, and why bis is used? Because ethane diamine, already that word di is being used. So, this is the compound Cl2. Now, the question is, it does not have a counter ion, which means that this complex, if needed, should have a charge. We know that this is a neutral ligand, this is a neutral ligand that we consider because there are no charges available. Chlorine is 1 minus, but because we have 2 chlorines, I will write it as minus 2. Cobalt is plus 3 given in the example. So, plus 3 minus 2, it means that there is plus 1 overall charge which is there. So, that plus 1 overall charge is indicated here. It does not have a counter ion, and that plus 1 overall charge is there. So, this is what the formula, you are able to see it on the screen there, which is COCl2 twice, Cl2, En twice plus. We will see one last example now, in this case Tetracarbonylnickel 0, which indicates that nickel is in 0 oxidation state and carbonyl group which is there is a neutral ligand. So, this neutral ligand, because it is 0, and this also they are told it to be 0, which means that they do not have any charge here outside, neither do they have a counter ion, because on their own itself they are stabilizing. This is a neutral ligand, this is 0, which they have given it already in the question. So, they are stabilizing on their own. So, this is how you can write the formulas from the names that are been present. So, I hope you have got a good idea now. So, that is why let us go into the rules that are being present in these cases. So, what do these rules say now? The rules say that the central atom is listed first. So, as examples, if you have seen earlier, the central atoms like nickel, cobalt, all those were listed first. Ligands are then given in alphabetical order. If you remember, we had amine, aqua, and then chlorido, like that. So, placement of ligand in the list does not depend on its charge, which means that some may have minus 1, some may have 0, some may have minus 2. So, the placement is not dependent on that, it is rather dependent on the alphabetical order that we consider. Even this polydentate ligand, say like En and all, it is dependent on the first letter that is present, E. So, that is why it has come after the chlorine forms. Similarly, further rules, whatever is written inside the coordination sphere are those which cannot be ionized. That is what we call it as writing in parenthesis, and parenthesis means nothing but in bracket. So, those ligands which have more than one atom, like say amine NH3, aqua H2O, all those are written in bracket systems. And whenever you write this ligands and central metal ion, it is part of one system, either positive or negative. So, you should write it continuously, nowhere you should give a gap in that. So, gap should only be given if it is a positive ion and negative ion. And whenever you write a formula, the charge on the central metal ion will be written on the end of the formulation that we say. So, whatever is the overall charge, it will be balanced by the total number of cations and total number of anions. If it is not balanced, it will have a complex part. So, that is why let us see in these parts which are there, in these parts we analyze now that once we shall go through all the examples that we have studied in these cases, and we will realize that we come across all these formula or rules that are present. So, the first example that we studied, what did the rule say? Central metal ion is written, then ligands are written in the alphabetical order, and whoever is present outside is the ion which is a counter ion. Similarly, the second example, you had a positive counter ion and a negative complex. The third example also had a positive counter ion and negative complex. The fourth example had a charged sort of coordination compound where cobalt was present with chlorine and En. Again remember that both those ligands were written in alphabetical order. The fifth one was depending on the charge. So, these are the rules which we already went through all now, and I hope you are clear with this. Now, all this time we were dealing with writing the formula from the names that were given to us. Now, let us see the other way around in this case. Suppose if you are given the formula, then how do you write the names for the compounds? That let us see, but before that we have to know a certain aspects here. Whenever you write names, all the negative ligands which are there should end with IDO, acetato, this fluorido, chlorido, bromido, these are all the individual ions, but if it is multiple atomic systems, we have acetate named as acetato, sulfate to sulfato, thiocyanate to thiocyanato. This is how the changes are being taking place in these cases. So, what we understand, we have already seen from naming to formula that it was given like that only, but here while writing we have to be aware of this. Some neutral ligands, they have specific names like aqua, amine, nitrosyl, carbonyl. There are some positive ligands which are pretty much rare, but their positive ligands naming ends with IUM. So, seeing these basic parts, let us now try to solve some examples in these cases. Now, here the way of solving is writing the name from the formula which is given. So, what is the formula that is given to you? The very first one, it is having platinum, it is also having amine forms in it, it is having a chlorine as well as it is having a NO2 present in that. And remember in this case that, so this NO2 is an ambidentate ligand, and when you write it as NO2, it means that nitrogen is the one which is coordinating. If you write it as ONO, it means that oxygen is the one which is coordinating. So, how will you write this name? So, this is the formula that has been given. So, whenever you write this, while writing, first start writing the amines in the alphabetical order. The best thing is that you need not search which is the alphabetical order. However it is written, it is bound to be in the alphabetical order. So, just start writing these names. How many amines are there? There are 2 amines. So, diamine. Remember, no spacing should be there in this compounds. Diamine. There is 1 chlorine. So, I am going to write it as chlorido because it is a negative ligand. This is named as nitrito, but since this is an ambidentate ligand, the examples for ambidentate ligands are NO2 and SCN. These are the major 2 examples for you at this level, where in this case it can be through sulfur or nitrogen, whereas here it is nitrogen or oxygen. So, when you have ambidentate ligand, you have to write it like this, nitrito N, which indicates that it is from nitrogen, nitrito N and platinum. This is how we tend to write, but now we have to also see the charge that is present. This is -1 and this is a neutral ligand. So, the overall charge will be +2 in this case. So, you can see here now that the formula is taken up and the corresponding name is given as diamine chlorido nitrito N platinum. the 2 indicates the overall charge. So, as I have already told you, this chlorine will be -1, NO2 will be -1, this is neutral. So, to balance this, I need to take up the charge of platinum as 2, and this is written in Roman numbers. Let us now see the second example which has been present is having a cobalt. It is having a chloride ion in that case. It is also having En, which is ethane 1,2 diamine, and chloride outside. So, let me explain those parts there. First, we have to start writing the balancing of the ligand parts. There are 2 chlorines, so that is why it starts with dichlorodobis. Bis, because as I had told you, if there is a word di-tri in the name, we then have to go for bis, tris and all. So, it will be bis ethane 1,2 diamine, cobalt, 3 chloride. Now, from where did you get that 3? Please observe the formula perfectly. En is 0 because it is neutral, Cl2 is inside, 1 Cl is outside. So, in total there are 3 negative charges. So, if we have to balance those 3 negative charges, the charge on cobalt should be +3. Seeing the next example here, what are the ligands? Amine, 5 amine are there. So, start with pentamine, CO3 is carbonato, cobalt, and outside the counter ion is chloride. Why is the cobalt charge 3? That is what to be analyzed. Amine is 0 because it is neutral. Carbonate, CO3 is 2 minus. We have come across this in many compounds like calcium carbonate, potassium carbonate and all. So, CO3 is 2 minus, Cl is 1 minus. So, the overall 3 negative charges are satisfied by the 3 plus charge on cobalt. Now, the question is, all these cases, if you see, we were having the central metal ion in the positive part, but if it is in the negative part, then what we have to do is, we have to use its Latin name and end with the name as ate. Iron should be ended as ferrate, cuprate, argentate, aurate. That is what the examples you are able to see. So, in relation to this, let us solve one example here, which is nothing but potassium compound is present in that formula. There is also the presence of a central metal ion, which is chromium in that case. You have oxalato as the ligand which is present. So, how do you name this now? Potassium. Remember that we should not write this as tripotassium. Whenever whoever is outside, they are only given by the name. You should not specify whether they are di, tri and all. Who are inside, you have to specify them. So, what is the part that you are going to write inside now? Potassium. What are the ligands? So, start with the ligand. So, the ligand that is present here is trioxalato, and since chromium is in the negative complex, take a simple example NaCl. Once again, this is the positive part, negative part. So, if it is in the negative complex, then the name should end as chromate. That is what they tend to tell. And what is this form here? This is nothing but trioxalato. So, what does this indicate is potassium trioxalato chromate. You have to end it because it is in the negative complex. So, what is the charge on this now that we have to determine? We know this is 2 minus, and since there are 3, the overall charge is -6. This is +1, and since there are 3, we will write it as +3. So, this will be +3 so that it can be balanced. So, therefore, the name of this compound will be in 3, potassium trioxalato chromate. That is what the name you get. Similarly, another one, mercury tetrahydroxozincate. So, why is this? Because the mercury part which is there is in +1 state. Tetrahydroxozincate SCN has a charge of -1. So, in total there are 4 negative charges and mercury is giving +1. So, if it has to balance, cobalt should give +3 charge. So, having seen all these examples, let us go through some of the rules now that were to be followed with this. The cation is named first in both positive and negatively charged species. We have seen, however it is, the cationic part is written first. Ligands are written in the alphabetical form. The ionic forms which are there, if it is anionic ligand, you have to end it with O, or you have to end it with the forms like multiple, like acetate should end up as acetato, like that. Neutral ligand will have a special name like aqua, amine, carbonyl, etc. Similarly, whichever there are mono, di, tri, if they are there, we have to name it based on the number of ligands that are present, but if there are already having the name of di and tri, we should go for bis, tris and other forms. So, oxidation state of this should be named and it should be written in the Roman number systems which is there. So, any neutral complex which is there, if it is a neutral complex, the overall charge should be equal to 0. Otherwise, we have to write it according to the charge that is available. So, considering these rules which are there, let us now once go through all the examples that we happen to study till now regarding these cases, so that we can see how we have applied these rules. We are able to see that the first part is the cationic part, potassium trioxalatoaluminate, so cationic part is written, anionic part is written separately. You then have mercury which is there, which is the cationic part, so that is first one I have written, and then I have written the anionic part which has been present. So, these were the things that were present which were based on these rules for writing the formula as well as for writing the names of these compounds. So, I hope you have understood about naming these compounds, or to say writing a formula from these names in these cases. So, having seen all this, let us see at some homework that can be done by you, where I have given around 6 names of these compounds. Please try to write the formula of this compound so that you are able to write it perfectly. Please consider the charges, please consider the overall number of ligands that are present: tetramine diaqua cobalt 3 chloride, potassium tetracyanonicolate 2, tris ethane 1,2 diamine, which means that the diamine ethane 1,2 diamine is present in 3 numbers, chromium 3 chloride. The next one is platinate, which indicates that it is a negative complex. The platinum which is present is in the negative side. Dichlorodobis ethane 1,2 diamine platinum 4 nitrate, and the sixth one is a little tricky because that has not been explained directly here, but if you can think over a little and try to apply whatever you have studied, I am sure you will be able to find it. The other way of writing these, where you are given the formula and now you are being asked to write the names of these compounds. So, earlier names were given, you are asked to write formula. Now, please try to write the names of these particular compounds, and by IUPAC name it means that including all the ligand factors, including the counter ion factors which are there in these cases. So, this is all that was there for this part of nomenclature of coordination compounds, and we will see you with the further parts and with a good understanding of these first 3 parts. Thank you. Sai Ram.